All right, you guys, what we're going to do today is go over this quiz. I gave this a week ago, I think, and I graded it today, and there were several of y'all that didn't complete it correctly, so I wanted to give y'all the solution. All right, and for those of y'all not in my actual class, this is over constrained motion of particles. And this problem here is from one of the Merriam-Craig textbooks. All right, so what we have here, we have sliders A and B. They are connected by this light rigid rod right here, and they're going to move with negligible friction in the slots, both of which lie in the horizontal plane. Okay, so horizontal plane is going to be important later on when we do our free body diagram. For the position shown, the hydraulic cylinder is going to impart a velocity and acceleration of the slider A of 0.4 meters per second and 2 meters per second squared respectively to the right. We want to find the acceleration of slider B and the force in the bar at this instant. Okay, so two things we are trying to find. Now, when you see a problem like this, you have this bar that's connecting the two masses. All right, so usually on the constrained motion of particle problems, you're going to have a pulley, you're going to have a bar, you're going to have something that connects the motion of the two masses. And that's what we've got here with this 0.5 meter bar. All right, so that means if A moves, B has to move because it's constrained by this bar here. So that's how we know by looking at this, you can use the concept of constrained motion of particles. Now, what I'm going to do first is I'm going to draw out this triangle, because if you look here, you can see a triangle. So let's draw that out and put all of our angles in here. All right, so it looks kind of like this, and here's A, we've got B up here, and now if we look at our angles, this is 30, which is right there, and what else do we know? This here is 60, so if this is 60, what does this have to be? 120. All right, well, now we have 120 and 30 inside of the purple triangle. So what does that mean for our other corner up here? That's 150, so then we're going to have 30 up there. All right, now we've got that. Next thing I want to do, because I am doing the constrained motion of particles, I need to label my variables I'm going to be using. So it's easy for the person grading your work, or you, to figure out what exactly you're talking about. So let's say that this distance here, let's call that SA. All right, we got that. And then let's call this distance here SB. Okay, so those are going to be my two distances. And remember, this length here for this rod is 0.5 meters. Okay, so now we've got that. Now what I'm going to do, if you look, we've got this little triangle here. So what I'm going to do is I'm going to use the law of sines to find SB and SA. All right, so let's do that next. Whoops. So with that, we're going to have 0.5 over sine of 120. And then that's going to equal SB over sine of 30. All right, so now we can solve for SB. Well, I wrote that backwards. So SB is going to be 0.289, and units there would be meters. And then we can do the same thing for SA. If you look at this triangle, though, you should be able to see that you're going to get the same value for SA, but we'll write it out anyways. So for this one, we're going to have the 0.5 over the sine of 120. And then for SA, I got this. Opposite angle here is 30, so I'm going to have SA over sine 30. So exact same equation I had up above, so that means SA is going to be the 0.289 meters. Okay, so SA equals SB. So now we've got that. Okay, and this will come in handy in just a little bit. Now what I want to do is I want to get an equation that's going to relate the motions of these two things. Okay, so the bar relates the motions together, right? So I want to get an equation for the length of this bar. And if you look, we have this triangle. We can use law of cosines to do that. So law of cosines would be L squared. So I'm going to call this L. So we'll call it L squared, and that's going to equal SA plus SB minus 2 SASB, and then cosine 120. All right. So this is just law of cosines, and remember the angle here is always going to be the one across from the length on the right, or the left, sorry. Okay, and then I forgot these squared. Forgetting everything here. Okay, so now I've got that. And what we need to do now is, if you notice, we're given velocity and acceleration. So what I'm going to do is I'm going to take the derivative of this expression here, and then I'll be able to find velocity. So let's go ahead and find the derivative of this. Now you want to take the derivative with respect to time. Okay, so any length that's going to change with time, we have to take that into account when we do the derivative. So on this one, L is on the left. Now L is 0.5 meters. So if I take the derivative of 0.5, is that going to have a change? No, right? Because this is a constant. So it's constant, so that means the derivative here is going to be 0. All right, so we're going to have 0. And we can put a little note. All right, because that's constant. And then now we're going to go through and take the derivative of this term. So for this, we're going to have 2 times SA. Now, SA is going to change, so we have to multiply that by SA dot. Same thing for this next term. We're going to have 2 SB times SB dot. All right, and then now we get to this term here. All right, so I'm going to pull this 2 out, that negative 2. And then inside of here, I'm going to take the derivative of SA, multiply it by SB cosine 120, and then I need to do that second term. So for the next term, I'm going to leave SA alone. I'm going to take the derivative of SB and then have cosine 120. All right, so here we'll have SA, SB dot, cosine 120. Kind of out of room here. So now we have this expression. Now, if you do cosine of 120, if you plug that into your calculator, you're going to get negative 0.5. Notice you have a negative 2 here. So those are going to cancel each other out, right? It ends up being a positive 1 when you do negative 1 times negative 0.5. Okay, so the cosine 120 and the 2, those are going to go away. So let's kind of simplify this and rewrite it as 0 equals 2 times SA. Now what's SA dot? Well, that's the time rate of change of this length here, right? So essentially that is the velocity of A. And then we'll have plus 2 SB times SB dot. Well, that's the time rate of change of this length. So this would be VB. And then we get over to this part. Remember the negative 2 and the cosine 120 cancel out. So now we're going to have VA times SB. And then we're going to have SA times VB. Okay, and now you've got that. Now what I'm looking for here, I want to find the acceleration of slider B, right? It's not in here yet, but I'm going to use the velocity of B to find the acceleration. So we need to solve this for VB. So let's go ahead and let's look at our values here. SA, I know what that is from right here. So we're going to plug that in. VA was given as the 0.4. So we've got that. So let's plug those numbers in. So we've got 2 times the 0.289. Then we have VA, which is 0.4, plus 2 SB, we know that, so 0.289, times VB, I do not know that, so leave it as VB, plus the VA, which is 0.4 meters per second. SB is the 0.289. And then finally that last term. So we'll have 0.289 for SA, and then VB is unknown. Okay, so we're going to go through this, simplify it, and you'll get 0 equals 0.3468 plus 0.867 VB. And now you can solve for VB. All right, so VB is going to be negative 0.4 meters per second. All right, that's not one of the answers it wanted, but we're going to use that to find acceleration. Now, if you notice when I used the velocity of A, I left it as positive. That's because I defined this line as starting from here and being positive going to the right. It told me the velocity was 0.4 going to the right, so that's why I used positive here. This negative VB that we have, if you look at my sign convention, I'm saying going in this direction would be positive, so I got a negative. All right, because obviously if A is moving, to the right, B has to be moving down, right, which is the opposite direction of what I have drawn here. Okay, so that's what that negative means. Now I want to get acceleration. All right, so let's do that. So to get acceleration, we're going to take this equation here. We're going to take the time derivative again. All right, so each time you do the derivative, your equation tends to get a little bit longer. So left side would still be 0. And now remember, everything that's going to change with the time, you have to include that when you do the derivative. So with this, I'm going to have 2 SA dot VA. And then we got to, doing the product rule here, I got to take the derivative of VA. So the second term from this piece right here is going to be 2 SA VA dot. Do the same thing on this one. So we're going to have 2 SB dot VB plus 2 SB VB dot. And then come over to this one. All right. So now we're going to have VA dot SB plus, oops, I was about to switch the order here, plus VA times SB dot. And then finally, do the product rule here. So we've got SA dot VB plus SA VB dot. Okay, so now you've got this long equation. And doing the derivative is usually where people mess up, especially if you have a bunch of trig functions in there. Fortunately, this one didn't have them, but just pay close attention to when you're doing your derivative. Remember, anything that can change with time, you have to keep that in account when you do your time derivative. Now let's go through and rewrite this in terms of V and A for acceleration, so it's easier to see what's going on. So 0 is going to equal 2. SA dot is VA. We're multiplying that by VA, so let's put 2VA squared. This next one here is going to be plus 2 SA. What's VA dot? Acceleration. So we're going to have acceleration of A. For this next one, we've got 2. SB dot is VB. We're multiplying that by VB, so let's put 2VB squared. Next term right here, we're going to have 2 SB, and then we have VB dot, so that's AB. Right here, VA dot, that's acceleration of A times SB, and then plus VA times SB dot, which is VB. Then we got SA dot, which is VA times VB, and then finally SA times AB. And now, just like what we did up here, you're going to take your numbers that we have, we're going to plug them into this long equation. All right. So let's go ahead and do that. So 0 is going to equal 2 times VA, which is 0.4, square that, plus 2 times SA, that was the 0.289, times acceleration of A, which was given as 2. It was also going to the right, so I'm going to leave it as positive. And then we're going to have plus 2 times 0.4 squared for this term here. Next, 2 times SB, so 0.289, times AB. I don't know what that is. That's what I'm looking for. Next, we got acceleration of A, which is 2 times SB, 0.289. Then VA times VB. All right, well, I know what VA is. It was 0.4. VB is negative 0.4. Because we found that up here. And then 2 more terms, right? VA is 0.4. And then we have negative 0.4. All right, so now we have that. And then finally we have this last term. So SA times AB, which we don't know what AB is. And then after all of that, you got to go in and simplify, and then we'll be able to solve for acceleration for B. So if you simplify, you get 0 equals 2.054 plus 0.867 AB. Now you can solve for AB. And for this one, you're going to get a negative again. So negative 2.37 meters per second squared. All right. Again, it's negative because I said going up was positive. So if it's negative, that means it's accelerating in, this direction here. Coming down. Last thing we need to do is find the force in the bar. So for this, we're going to need a free body diagram. And I'm just going to look at B here because it's got fewer forces on it. So we're going to have a normal force. If you look up here. Now this rod here, this bar, is kind of pulling this, so it's going to be pushing up against this wall. So the surface is going to be pushing back down. Okay, so we're going to have an N here. And then we've got the force in the rod, so that's going to be T. All right, and there's an angle of 30 degrees there. And we know that 30 degrees is there from our triangle right here. All right, because your T would be right there. Okay, so now we've got that. And let's set up our coordinate system. I'm going to say that's X, that's Y. So then if we look at, let's see, I'm going to make it the other way. Make it this way. So let's look at the X direction and let's see what we got. So for the X components, I'm going to have T cosine 30. All right, and I kind of switched my notation here. All right, let's fix that. Let's make this positive going up. That way it's consistent with this right here and up here. Right, because I said going up was positive. So let's keep that consistent so we don't get confused. Okay, so if that's the case, then the T component is going to be negative because it's obviously going down the incline. And that's the only thing we have in the X direction because N is going to be in the Y direction. So I'm going to take that and I'm going to set it equal to mass, which is given as 3 for slider B. And then I need the acceleration for B. Well, that's the negative 2.37. Now T is our only unknown, so we can solve and we get 8.21 newtons. Okay, so there you have it. All right, so on that one we had free body diagram work to do, and then you also had motion of constrained particles to do. So kind of a long quiz problem. But hopefully that makes a little bit more sense now. So I will see you guys in class next time.